Hi and good day to everyone. We are the Group 4 from Grade 10 Brother Arcages, and today we will be presenting our investigatory project, which is the sensor-activated alcohol dispenser and thermometer. Starting off with the background of the study, the researchers hope to utilize and take advantage of the use of technology using automated sensor for temperature, scanner, and alcohol would be more likely to lessen the contact rate of people, and there is no more need for a health worker to risk their lives by monitoring and interacting with people who enter a facility. Researchers have noticed that when people go to supermarkets, malls, and other indoor public places, it is mandatory to clean your hands with alcohol and get your temperature checked and recorded. The researchers decided that this topic to be the title as it is one of the relevant things that the world needs in further decreasing the rate of contagion of COVID-19. The idea of the researchers had come up to combine these two objects to save time, minimize the possibility of spreading germs and viruses, and hopefully become cheaper and more affordable for the public to use.
Statement of the problem. This study aimed at developing a sensor-activated alcohol dispenser and an automatic temperature checker to test its efficacy on reducing the risk of COVID-19. Number 1. How is a sensor-activated alcohol dispenser be any different from any regular alcohol dispenser? Number 2. How will this piece of technology help reduce the risk of COVID-19? Number 3. How accurate will this temperature checker will be? Significance of the study. This research will help people feel more secure and safe, especially when going out. The researchers believe that the sensor-activated alcohol dispenser and thermometer will help make safety protocols more efficient. The job of the frontliners will be lessened, plus the sanitation and disinfection will be monitored properly. More to this study, it will benefit all the people in this current situation of the COVID-19 pandemic, since the device will be able to help sanitize and check temperatures accurately and will take up less time in public or private places and establishments.
Scope and limitations. The purpose of these two focuses on the safety for the people from the pandemic, and it tackles from the exposure of the virus. The researchers have come up to an idea on making or inventing an automated temperature checker and a sensor-activated alcohol dispenser. The automated temperature checker scans the body temperature. It scans whether our temperature is normal or it's at higher risk. If your body temperature is at 36.6, that's fine. It's normal. But if it's more than 36.6, it's getting worse. Next up was the sensor-activated alcohol dispenser. The sensor-activated alcohol dispenser triggers when a human hand is detected. Overall, the alcohol kills 99.9% of germs, and to which our hands can be firmly smooth and feel hydrated. These things can help maintain in every location, like gyms, hospitals, schools, every building, to prevent the spread of the virus.
The materials that the researchers will need to accomplish are the following: a pole with a height of 120 centimeters, a flat round metal with a diameter of 20 inches, 50 flat screws, one drill and one drill bit, one metal box with the height of 5 inches and the width of 5 inches, one rectangular metal box with the height of 5 inches and the width of 10 inches, 3 thin metal sheet with the width of 10 inches, one red LED light, a plastic container. This will be used to store the liquid, and it should be at least one size smaller than the rectangular metal box, one OLED display, one small breadboard, one Arduino Uno board, MLX 9061 for IR contactless thermometer, ultrasonic sensor, 15 resistors, one capacitor by 0.1 UF or 100 NF, 20 jumpers, one PIR sensor, one microservo, one battery C, one battery container for battery C, a half gallon of rubbing alcohol, and a switch. Step 1. Gathering of materials. In an experiment, materials are essential in accomplishing the task. The researchers would be gathering the materials needed for the study. Step 2. Construction of the structure and making necessary holes. This is where we will make a stand with the pole, flat, round metal, the metal box, the rectangular metal box, and holes will be drilled for wires and for the sensors. The drill bit will be required during this process. Next is step 3. Setup of technical objects and connecting wires. For this step, the placement of the OLED display will be drilled in a hole near it for its wire to be connected to the Arduino. A small hole will be drilled inside the rectangular metal box, making a small passage to the metal box below it and placing the servo inside the rectangular metal box, making sure the dispenser is at its rightful hole. The sensors will be placed in front of the metal box, making sure that they are in their rightful holes as well, and securing it with screws. After this, we will connect it to the Arduino breadboard and connect it to the OLED display with the sensors. We will fix and organize these wires first before connecting it to the battery container, red LED light, and the switch. Next is step 4. A small hole will be drilled on the side of the metal sheet for the red LED light, and the researchers will secure the placement of the battery container and the switch on the opposite side of the metal sheet. This will be placed on the back of the metal box, closing it completely with screws. We will place the plastic container for liquid will be placed in the rectangular metal box. During this process, we will also connect the servo to the container. With a metal sheet, screw the top, leave a rectangular hole, and a small door will be made. Next is the 5th step, coding of the functions and sensors. This is the function that we will be coding. The sensors will check if there are any movement and will be sent to the Arduino. The Arduino will then check the signal output, and if there's none, the sensors will keep looping. If there is movement, it will activate the thermometer and will send a signal to the Arduino to first input the temperature in the OLED display, and with the 5 seconds delay, it will activate the spray and it will return to the sensors checking for movement. Next is the final step, observation and gathering of data. For testing, the researchers will pour the alcohol inside the plastic container via the small opening on the top of the rectangular metal box. When testing the finished product, hover your hand to the sensor if the code worked. Check for any mistakes and/or misfunction and fix it right away using the extra leftover materials there must be after building the finished product.
Cost analysis in this project, the researchers used a 120 centimeters high pole amounting to 293 pesos, a 20 inches flat round metal amounting to 804 pesos, 50 flat screws amounting to 3 pesos each, cumulatively 150 pesos, a drill already owned by a researcher, a metal box amounting to 243 pesos, a rectangular metal box amounting to 480 pesos, 3 thin metal sheets amounting to 289 pesos each, cumulatively 687 pesos, red and green LED lights amounting to 78 pesos each, a plastic container amounting to 180 pesos, a LCD 16x2 amounting to 112 pesos, a breadboard amounting to 77 pesos, a Arduino Uno amounting to 205 pesos, a MLX 90614IR contactless amounting to 680 pesos, a ultrasonic sensor amounting to 60 pesos, 15 resistors 6 pesos each, cumulatively 90 pesos, 1 capacitor by 0.1 microfarad amounting to 88 pesos, 20 jumpers, 2 pesos each, cumulatively 40 pesos, a PIR sensor amounting to 50 pesos, a micro servo amounting to 149 pesos, a buzzer amounting to 10 pesos, a charger adapter, it is already owned by one of our researchers, a half gallon of rubbing alcohol amounting to 300 pesos, and lastly, a switch amounting to 20 pesos. All in all total, 5,054 pesos. All of the materials are bought from Shopee, and that concludes our investigatory project.